I'm going to demonstrate a titration for you. Before we titrate, I need to show you the burette. So this is the equipment that we're going to use today. One is filled with an acid and one is filled with a base. So it's basically like a long glass straw, and at the bottom it has a valve, and the valve works very much like the gas jet. When the handle is parallel to the table or the floor, it's closed, and if we turn it to the left or the right, any way so that it's not parallel to the table or the floor, then liquid will either stream out if the handle is straight up and down, or it'll drop out little by little, depending on where you position it. And I'll show you that in just a minute. So they're both attached to this blue burette clamp, which is labeled for this one is the acid and this one is the base. And the very first thing that we have to do is read the burettes and record that on the data table. So these are pieces of equipment that are made to dispense liquid, not contain it. And so as a result, they're numbered from the top down. So when it's filled all the way to the top, we would write down 0 because 0 milliliters have been dispensed. So what I'm going to do is hold a piece of black paper so it's a little bit easier to see the numbers. And if the meniscus was right here, it would be 18. And if it was right here, it would be 19. But it looks to me like it's right in the middle, so I'm going to call that 18.50. And then I'm going to use that same technique over here to read this one. And this one looks to me to be 20.6. So I'm going to record those on my data table down here as my initial volume. And notice that I'm going 2 digits past the decimal point, because that's the accuracy that we should use whenever our equipment is graduated in the 1/10 of a milliliter. Let me show you some of the other equipment that we're going to use today. When you titrate, you're always going to use an Erlenmeyer flask, and that's because its shape is especially suited for this. We're going to be doing a lot of swirling as we titrate, and the liquid could slosh out if we were using something that had straight sides like a beaker. So you want to make sure you're using an Erlenmeyer flask. And then this is called a wash bottle, and we're going to use this to rinse the tip of the burette, and also sometimes we'll rinse the insides of the flask to make sure all of the things in our reaction mixture get mixed together well. And we're going to use universal indicator when we titrate today so we can monitor the pH of our solutions as we mix them. And we have this indicator card that shows us what color universal indicator is every pH unit or half unit between 4 and 10. So you can see as I hold it on the white paper that at a pH of 4 or below, it's red, and at 10 or higher, it's purple, and then it changes just like the rainbow colors between there. So when we're doing our titration of a strong acid and strong base, this pH of 7, this nice green color, is what we're going for. So what I'm going to titrate today is hydrochloric acid and sodium hydroxide. And I know that my hydrochloric acid concentration is 0.1 molar, and I'm going to use it to figure out my concentration of sodium hydroxide. So the procedure is very easy. I'm going to start by putting a small amount of the acid or base, it really doesn't matter which one you start with, into the flask. So I'm going to go ahead and do that. It doesn't matter how much you start with, you can pick any quantity, so you just want to put some in there. And then I'll use the wash bottle to rinse the tip of the burette to make sure I got all the acid that I dispensed in there, and then rinse the sides of the flask. While you titrate, it's perfectly fine to add as much water as you want because that's not going to change the number of moles of acid or base that are in there and reacting. The next thing that I'm going to do is add the universal indicator, and that's so I can monitor the pH while the titration takes place. When an acid and base react, they make water and a salt, and since those are both clear, like an acid and base, we wouldn't have the typical signs of chemical change like a precipitate forming or a gas being released. So the pH change is how we're going to know that we have reached what we call our end point, which is when we get to that green neutral color. So now I'm going to hold the flask underneath the base burette, and I'm going to start to add it a little bit at a time. And I'm going to swirl the flask while I do, just to keep it all mixing. And what I'm looking for as I do this is a color change to happen that lasts a little bit longer each time in the flask. So as I add it, when I'm looking straight down on it, I can see that there's a little bit of a color change happening. But I'm going to look for sort of a splash of purple that sticks around. And when I see that, I'm going to slow down the rate that I'm adding the base so that I don't go too far and go past the end point. So you can see this is a green for sure. And if I was titrating for the first time, well, now I'm starting to like the color a little bit better. When I first saw it, I felt like it was a little bit too blue. So remember, you have that indicator color card, and you can compare to see, you know, how do you think you did. So I actually feel like this is pretty good. But just to show you what might happen if you go too far, I'm going to add a little bit too much base, and now you can see that it's purple. But that's okay, because now I'll just do the same thing and put it underneath the acid burette and add a little bit of acid. So that yellow is a pH that's a little bit too low. So I'm going to try a trick, which is to rinse the tip of the base burette and rinse the insides of the flask and hope that that's enough for me to get to green. And I like that green, so I'm going to go ahead and stop there. So now the thing that I would do next is read the burettes one last time. So I'm going to hold that black paper up, and that looks to me to be 20.90, which I'm going to record in the data table. And then in the base burette, I think it is 23.30. And then you would subtract these quantities to figure out how much acid and base you used. And then once you know that, you can complete stoichiometric calculations to determine the molarity.